Okay, welcome to the video on Introduction to Two-Dimensional Geometry. By the end of this, you should be able to classify and name different two-dimensional shapes, determine which properties classify it as quadrilaterals, and then we're going to work a little bit with circles and their circumference. So when we talk about classifying triangles by their sides, you can copy along with this document that's at the bottom of the videos page. I'd recommend printing it off if you don't want to draw everything over, or else you'll want to pause and take down these shapes and their vocab. So if you're talking about their sides, when we have little tick marks on all the ends, remember that those are saying that they're congruent. So if you have something that has 3 tick marks all the way around, that's referred to as an equilateral triangle. So if all 3 sides are the same, you can infer that all 3 angles are also going to be congruent. Isosceles is when 2 of those sides are the same and 2 of the angles will also be the same. So the 2 congruent sides on the bottom of those, they're also going to create 2 congruent base angles. Okay. In scaling, we have a 1 tick mark, a 2, a 3. That just means that none of those sides are the same as the others. With angles, we are pretty familiar with this already. If all 3 angles are smaller than 90 degrees, you refer to that as acute. If you have one angle that is bigger than the 90-degree angle, that classifies it as obtuse. And then you should see the sign that says that it is a right angle with this little notation right here. So if it has one right angle, you refer to it as a right triangle. So when you classify triangles, you should be classifying them first by their sides and then by their angles. And the order doesn't really matter as long as you identify both. So for instance, if you look at this one, put yourself a little indicator here, and you see that none of the sides are the same, therefore it is scalene, and it has one right angle. So you can call it a scalene right triangle, or you could switch it around and say a right scalene. The order doesn't matter again, but make sure that you've identified it by their side classification and by their angles. Right? Any four-sided shape we know as quadrilaterals, but there's lots of different quadrilaterals within this category. So in a rectangle, we know that all 3 sides add up, or all 3 angles total to 180, because essentially there are 2 triangles in any given quadrilateral. All angles of the quadrilateral add to 360. All right, so it's 360-degree total angles. Okay. If you have something that looks like this, and you have one notation like so, another notation like so, you'll see that I have 2 sides of parallel lines, which classifies it as a parallelogram. Trapezoid only has 1 set of parallel lines. Okay? So it is a quadrilateral with 1 set of parallel lines. And then the rectangle is important because it is a parallelogram still, so we have a length equal to a length, a width equal to a width, but it's more specific because all 4 angles have to be 90 degrees. A rhombus is also a parallelogram, so see that it's coming down from this particular field of the quadrilateral, but all 4 sides are going to be the same. So it does not have to have right angles, but you notice that this angle would be the same as this one, and then the smaller acute angle is going to be the smaller acute angle here. Right? The most specific that we can get really is the square, which is a rectangle because it has 4 right angles, and it's a parallelogram. But it's a special rectangle because all 4 sides are the same. So it's kind of like a rhombus, except that it has to have 90-degree angles all the way around. Classifications of polygons and what they are. So if you look at this little chart down here, polygons, of course, has to be a closed-sided figure made up of straight segments, so no curving. Therefore, a circle is not a polygon that has to be on the same plane. So anything lifting up off the page cannot be considered a polygon. If it's has essentially chunks missing out of it like this, if you're dipping inside of the shape, that's known as a concave, and vice versa with the convex. This chart, familiarize yourself with. You should be able to identify the polygons based on how many sides that they have. If all the sides are the same length, you would refer to those as regular polygons. Okay? Very important in dissecting the different parts of polygons. Height and base are going to be essential when we get to areas. So first off today, you have to know how to identify the height and the base. And basically, they're the ones that are going to be perpendicular to each other. So sometimes the height can be outside of the figure, and notice that the height is perpendicular to the base. Sometimes it could be a side length of the figure, and then sometimes it could be within it. So again, you're looking for where the 90-degree angle is happening. That's the base and the height. It's going to get slightly more complex because sometimes we'll be dealing with shapes that have more than one base. But again, the height has to be perpendicular to the base or bases. So for instance, if we have something like this, I have a height that is perpendicular to this line and this line. So both of these are known as the base. In a parallelogram, the bases are congruent, but if you have a shape like this, which is just one set of parallel lines, a trapezoid, we have one height that's going to be perpendicular to two bases. And in this case, I have a short base and I have a long base. So base does not mean bottom. It means whichever line or lines is perpendicular to a height. So not always will you have the dotted lines given, but that's a pretty good indication to see which is your height. Okay, so if you look at this example, I'm asking for the height of the trapezoid. Well, I have one line that's perpendicular to 9 and 14. Therefore, 12 centimeters is going to be the height. And since 9 and 14 are parallel to each other, those are going to be the bases, right? So base is the perpendicular distance, or height is the perpendicular distance between the bases, right? So just start using the vocabulary of these shapes as much as possible. Any point is known as a vertex, and if there are multiple of them, it's vertice. The edge is the side of each polygon. And then regular, I mentioned earlier, is when all the sides and all the angles are exactly the same. So an equilateral triangle, a square, a regular pentagon would have 5 sides that are all exactly the same. All right? So for your first two now, go ahead and pause and copy these figures down. And I want you to identify the base and the height of the following. All right? So on example A, the only two line segments that I have that are clearly marked as being perpendicular are 7 and 11. Even though 6 and 8 may look like they're perpendicular, 7 and 11 are the base and the height. So it doesn't exactly matter which you label as the base and which you label as the height. But again, height is typically the one that is dotted. Right? On B, again, I have another trapezoid, and I have a right angle here, and the height is the distance between the two bases. So really, if I had rotated this, this is your typical trapezoid. 10 and 12 are our bases because they are parallel to each other. Therefore, 8 is our height. So 8 is the height. 10 and 12 are both bases. So we have a base that is 12 and a base that is 10. On the last one, we're looking at a parallelogram that has an external height here of 3. So 3 meters would be our height. And because it is perpendicular to 4, so if the top segment is 4, the bottom is also 4, 4 would be our base. So base and height have to be perpendicular. Okay? And as a brief review, we know that perimeter means around, so if you add up all of the segments on the outside of a figure, we can calculate the perimeter. And perimeter is one-dimensional, and you have to have units even if it's that generic unit. Okay? So for these 3 examples, you can copy it down and we'll do them together. This rhombus, it's 4 inches on one side, so there are 2 ways that you can show work for the perimeter. You can either label every single side, and then do your work in the calculator, or you can write down all of your calculations and then give us a final total. So if I wanted to be smart about this one, I would probably say the perimeter would be 4 plus 4 plus 4 plus 4, or simply 4 times 4, which is 16, and give it the units inches. And perimeter is one-dimensional, nothing is squared, nothing is cubed. Right? Number 2, I could add them all up, or I could show what each line segment is. So if this is 14 here, the bottom one is 9, and that is congruent to the top one. I can label this 9 centimeters. 5 centimeters is congruent to this 5 centimeters, so across the way I have 5. And then I come to a line segment that I don't really know, but I do look across and see that all 3 of these line segments that I don't really know are equal to the 14 across the way. So one way you could do it is saying all of this here is 14 centimeters. Now that every single one of them is essentially labeled, you would find a systematic way of adding these in your calculator. So I recommend starting at 1 and then maybe going clockwise. So I could add 9 plus 5 plus 14 plus 5 plus 9 plus 14. All of my numbers are accounted for. When I had equal, this should be our perimeter, which is 56 centimeters. Okay? These shapes that are sort of made up of different shapes are known as composite figures. So composite figures may not look like any polygon that we know, but this guy is essentially the combination of a larger rectangle, 15 by 9, and then a smaller rectangle, which is 5 by some little segment there. Okay? So you can look at them as various shapes put together. On number 3, we have a couple of missing pieces. I know that 20 meters is the distance across here. So I know that 20 meters will also be the distance across here. So even though it's broken up into 1, 2, 3 segments, it's still just as long as the one on the bottom. 10 meters on the left, 10 meters on the right, and now we got to figure out what this distance is and what this distance is. And the only piece of information we know is that across this is 2 meters. So you figured if this is 2 meters and the long side across from it is 10, then the difference that I've highlighted here in red is going to be the difference between 10 and 2. So this is 8, and this is also 8. So with those calculations, I'm not going to include 2 there, it's just going to be 8. I can find the perimeter. Start at the top, work your way clockwise, 20 plus 10 plus 20 plus 10 plus 8, and then plus another 8. Plus 8 gives us, oh, what happened here? Oh, I put too many of them. So let's see, 20 and 20 is 40, 50, 60 plus 16 is 60 plus 16, 76 meters. All right, so perimeter can be a single shape where you can show us everything that's being added, or if it's a composite shape like this, tell us what every single side on the outside is, and then you can do the rest in your calculator. Finally, we have a review of circles. And circles, the perimeter for a circle, because it's not a polygon, has a specific name called circumference. So circumference, like a circle, is around. The radius goes from the outside of the circle to the center in the middle, and it can be calculated by circumference is equal to 2 pi times the radius, and in algebra all of this is multiplication, or simply you can say circumference equals pi, that's the pi symbol, times diameter. And like any algebraic equation, I can manipulate this around and kind of isolate whatever I want. So if I wanted to say pi, I could depot out 2 times the radius, so pi is equal to circumference divided by 2 times the radius. Likewise, I can do it with diameter and say that pi is equal to the circumference divided by the diameter. Or you might hear this as pi is the ratio of the circumference of a circle to its diameter of the circle. Right? We can also solve for, say, r. How do I get r by itself? Well, I depot 2 pi, so r would be circumference divided by 2 pi. Likewise, if I wanted to solve for d, I depot out the pi, so diameter is equal to circumference divided by pi. So from this basic equation, you can manipulate it around and solve for several different things. Right? So we have to talk about now if I want you to use exact pi or approximate pi. If pi is approximate, you're using 3.14. Not the calculator button on your, not the pi button on your calculator, but 3.14 and that at the hundreds place. If we say exact pi, you're going to keep this Greek symbol pi as part of your answer. For instance, in example 4, we tell you to calculate the exact circumference of the circle that you see. So when we say exact, we are looking for this as part of your answer. So we know that circumference is equal to, we're given a diameter, it's all the way across, so we can use pi d, and the diameter is 9, so your circumference is simply 9 pi feet. So exact circumference, again, means you're going to have this symbol as part of your answer. And you'll find that this saves you a lot of work down the line if you know how to use exact pi. Right? For example 5, again, the exact circumference, I'm given the radius, so you can use the formula 2 pi r. And then if r is 5, then if I plug it in like so, pi you're going to treat as kind of like an x, so the coefficient, which is 2 times 5, will go in front of that variable. And then don't forget your units in the end, right? So the distance around this circle would be 10 pi. So approximately it would be 10 times 3.14, or 314 inches. But exact would be 10 times pi. Right? If we look at number 6, make sure that you copy this down. What is the approximate radius of a circle with a circumference of 42.3 inches? If we say the word approximate, then we want you to use 3.14 as pi. So that would involve a calculator. Okay? So what is the radius of a circle with the circumference of this? So circumference, again, is 2 pi r. And then to find the radius, I'll go ahead and manipulate this around and use the equation. So we depot that out, just like on the other page. Radius is equal to the circumference divided by 2 pi. So if we plug in values, circumference is 42.3, 2, and then we're using approximate pi, and then our final answer we're going to round to the nearest hundredth. So we could do this all in one step. 42.3 divided by, open parentheses, 2 times 3.14 gives us a value of this, which we're going to approximate as 6.74. So 6.74 inches would be our radius, right? Given that particular circumference. Right? One more example before you try some on your own. If I ask how many more feet longer is A's circumference than B's circumference, and we don't tell you what pi to use, I would try to use exact pi whenever possible because it's less work. So for A's circumference, so circumference of A, we know is 2 pi r. And so this has a 4-foot radius, so 4 times 2 gives me 8 pi for the circumference of A. And the circumference of B, we also know is 2 pi r. So if I double the radius, I get 2. So we have 2 pi. And pretty simply, if I say how much longer is A's circumference than B, that implies that I'm going to be subtracting the two circumferences. And then if it doesn't specify, we can say this. We can simply say 6 pi inches. If it wanted you to round to the nearest hundredth, that's implying that you use 3.14. But instead of using 3.14 here and then here and subtracting these wicked numbers, I'm just going to do it at the very end. So this is exact. If I wanted approximate, I can simply multiply 6 by that approximate pi value once and only once, and then round the final answer as necessary. So this ended up being 18.84. So this would be the exact answer. This one would be the approximate answer. So for your your do now number 2, I'd like you to calculate the missing information using exact pi, so the pi symbol should be in it. Right? So for this one, circumference is equal to the diameter times pi. So diameter times pi, don't forget your units, that's how quick it is. Right? The diameter of a circumference with a circle with a circumference of 20.5. Well, circumference is equal to pi times the diameter. Therefore, diameter is equal to circumference divided by pi. So if I am using exact pi, my answer could be left like this. Put a unit on it. There's my diameter. All right? For do now number 3, you're going to calculate using now approximate pi, and then your final answer you're going to round to the nearest hundredth. Right? So A, you're looking for the circumference of this semicircle with the radius of 6 inches, and then B, you're given the circumference and asked to find the radius. All right, so go ahead and pause it and try it on your own. For the circumference, this is a semicircle, so we can calculate the regular circle using 2 pi r, and then you figured this is half of what I'm seeing, so you can divide that final answer by 2. And what's really nice is right here, before I even substitute anything, I can cancel these two here and think circumference is just pi times the radius, which is 6. And if I need to calculate approximate pi, in your calculator you would multiply 3.14 by 6 and make sure you have units on your answer. So you get 18.84, that looks familiar, inches. Right, which is the distance around this semicircle. For here, if I'm finding the radius from the circumference, we figured circumference equals 2 pi r. Therefore, the radius is equal to the circumference divided by 2 pi. Circumference divided by 2 pi. So fill in some numbers here. 312 is the circumference. 2 times 3.14 is what I'm dividing the circumference by. And in your calculator, if you're going to do this in one step, you're going to say divide by, open parentheses, 2 times 3.14. And then that final answer we can round to the nearest hundredth. So approximately 49.68. Give me some dimensions, and then you're done.